All right, we're back. We are Game 3001. That's Artificial Intelligence in the summer 2019 semester, and it's week 5, part 1 of our broadcast. We're talking about creating a grid for pathfinding purposes. One thing that we need to talk about first is your week 5. I put your assignment 2 up. Let's talk about it a little bit. So, assignment 1, just a refresher, is due tonight at, Friday at midnight. I see things this Friday. Friday at midnight, right? So Friday at midnight, I mentioned earlier that for the first session that for your assignment 1, if you submit late, let's say up to 10 minutes, I will not, remove any marks. So you have a 10-minute leeway, grace period, call it what you like. After that, it's considered a day late, right? So it'll be worth 20% less. And if you're going to do that, you might as well wait until, Saturday night at midnight to submit, because it's the same, you're going to lose the same marks, right? Give yourself time. Don't kill yourself to submit by 2 a.m. I'm not going to not dock marks if you keep working, right? So try and submit on time, because it's silly to lose marks for assignment 1. If you don't submit Saturday and you submit Sunday, it'll be another 20% for a total of 4% lost of your final grade. Yes? Give me a second. Let me get to there in a second. Thank you for that. I'll talk about bonus marks. So let me go back to assignment 1 for a second, because I think we need to talk about assignment 1. Because people have asked me about assignment 1 at length, and I want to make sure that we're good. So assignment 1, again, due tomorrow night at midnight. If you're late on Sunday as well, like I said, that's 4 marks off, 4% loss. That's crazy. Beyond that, that's like 4 out of 10. Monday would have been 6 out of 10, but I'm not going to accept anything past Sunday night. Right? So Sunday's your deadline. It'll close after Sunday, so whatever you have, Sunday's the last day you can submit. If you don't submit anything on Sunday, you get 0. Okay? So, not because I want to be a hard guy or anything, it's because I need to mark stuff, and it'll give me, I won't be able to mark anything unless I have it, so I need you guys to get it done by at least the weekend, worst case scenario, right? Hopefully none of you are late. Now, strategies on getting this done, like I said, seeking, arrival, obstacle avoidance, and fleeing are all worth the same. So if you can't do obstacle avoidance, don't do it. And then you get maximum 20 out of 25. However, you also get these possible 4 bonus marks, which you should all get, which is like add appropriate background music, text to guide the user. That's like easy stuff. A gamepad support if you really want to add it in so that you can move your target around. Sound effects for arrival, entering, leaving the screen. These are all things you guys know how to do for easy 4 marks, right? So if you don't get obstacle avoidance, you can still get most of the marks back. So if you don't do obstacle avoidance to do this stuff, you can get 24 out of 45, right? However, if you do obstacle avoidance and this stuff, you can get 29 out of 25, which I recommend, right? If you're trying to get that done, right? So you have a chance to get bonus marks. And also, what if you can't point your ship in the direction? You can't do look where I'm going kind of script. And all you do is you move your ship around, but it's not really looking where it's going. I'll still allow that, but you're going to lose a bunch of marks. And you're going to lose, for every time you do that, for example, seeking, I'm going to take 2 marks off. And if you did it for arrival, I'll take 2 marks off there. If you did it for obstacle avoidance, somehow, I'll take 2 marks off there. And fleeing, 2 marks off there. So if you didn't do obstacle avoidance and you don't look where you're going, you're probably going to lose 11 marks, right? Which means that the maximum marks you can get is 14 out of 25, plus a bonus of 4, which means you could still get 18 out of 25. Yes?
You're saying that if the ship isn't looking,
your ship that's pathfinding, right? That's seeking, is not looking where it's going. It's just like, yeah, that's bad. If you just somehow did that and you couldn't do it, yeah. Yeah, you have to go like one of these. Yeah, you maintain a distance away. Basically, obstacle avoidance, what you do is you would have a look forward vector, so something that you look forward ahead of the ship faster than it's actually going to move, right? So when you move, that look forward vector gets updated, right? And you keep looking forward. And when your look forward vector intersects through collision detection with the next object, right? Maybe you make it a radius. You can do a radius of the object, right? So if the collision vector and the distance between the collision vector and the radius is some small number or whatever, then you know that you're in range within the next 2 frames or something to collide. Then what you want to do is you want to have something called, you know, kind of a force to literally turn you to one side or the other, right? And what you can do is you can add turning force, right? Until you're clear, until what you're looking in front of you is there's nothing in front of you, and then just keep going there. That's one way of doing it. And then you keep going in that way. You know where there's an obstacle, and then you clear the obstacle, and you go back to seeking again, right? So you go away from the obstacle, like diagonally away, like way, and then once you're away from the obstacle and there's nothing in front of you. It'd be nice if it seeks nicely and slowly around, but sometimes that's not possible. The other option, cheesy option, the hack that you could also program in, is make your obstacle smart. And so you report to the ship that, hey, ship, I have a node you can travel to down here, right? So, hey, ship, guess what? You're close enough that there's a node over here, go there. And then it'll do one of these, right? And then it'll go there. And you can do that for every obstacle. But then the thing is, then it's kind of avoiding the whole feeling. It's more computationally expensive than what I'm talking about, because now instead of the ship having a feeler in front of it, which is your look ahead, you're actually creating feelers or nodes kind of around the obstacle, which is artificial. Anyway, so that's your obstacle avoidance. You can look it up online. There's some great examples of this that you can download from YouTube, at least, or watch YouTube to do something, or other places. But this part right here, part 6, is definitely the part that's going to cause you consternation, right? Just saying. Next, so you submit this thing, and remember that you need to give me a zip archive and all that stuff. That's all I'll do tomorrow. All right, let me move on, please. I'm going to move on to next assignment, which is assignment 2, which is due 2 weeks from now on week 7, okay? So again, I'm going to go to content. I'm going to go to week 5. Under week 5's content, you see this assignment 2, pathfinding. So this is due week 7. Again, that's June 20th by midnight. This is the last time that we're going to see each other is June 19th. I won't see you after that, right? Well, maybe I will. See if I can come in and see you guys for the last time, the week after intercession break. But that's really what's that? That's me. I'm done. Then it's just Alex after that, right? So, but week 7 will be the last time. Week 7 is also your exam week, right? So it's going to be at the same time. It'll be due the same time. That's why I'm allowing you to do it with a partner. If you choose, you can do it alone or with a partner. You can work with somebody else. Now, I'm going to ask you to make sure that everyone has something to do, all right? So, you know, don't just have one guy do it because he knows how to code and you don't. That would be bad. And I should be able to ask you at any time, tell me what you did. How did you make this pathfinding work? And you should be, any one of the partners who are working on the project should be able to explain to me exactly what's happened, which means please have people do different parts. So that way you work together on them. Pair programming is like this. You guys sit next to each other when you're coding, right? And you can even use that live share feature that I showed you, right? Turn on live sharing, and then what's going to happen is one person can code, the other person can sit there and go, hey, how do you do this? What about like this? And even if you put it in comments, like here's my thinking, and then you put it together, you guys can code together and get this done a lot easier than if you're on your own. That's why this is here, okay? So, so working together, you have to use a template that has a grid and tile system. I'm going to give you that today, right? So if you download a template version 4, it's really template version 3 with some stuff stripped out of it. We're going to keep stripping stuff out of it today. I'm going to put this up on GitHub so you'll have a clear example of what I'm looking for the grid and tile. Except today we're making dumb tiles. Next week we'll make smart tiles. What I mean by dumb tiles is they won't have really any property to know what's inside of them. They're not going to be containers right now. Today they're just ready to create them, and then next week we'll make them containers. Yeah. It's up to you. You can use whatever makes sense, but let me keep talking. So ensure you select an appropriate seeker sprite. So you can use the ship if you want, but if you're going to use the ship, then make sure that your obstacles are like planets or something like that, you know? Make it so that it's kind of makes sense for the simulation you're using, right? So I recommend that. So again, this could be a spaceship, a car, animated character, or something else that makes sense to you. That's worth 5 points. And then create an interesting map. So what I mean by that is, like, you know, maybe you can make a map that looks like, if you're going to make an animated character or some kind of tank, maybe you're going to make mountains and some kind of valley and grass and whatever. Just basically add the tiles in the specific spots you want, right? And this can be creative or not. And let me explain how you do it not creative. Ensure the map includes obstacles, mountains, walls, debris, whatever, that are impassable, so you can't go through them. And the tiles, smart tiles, should know that those obstacles, that position, you can't pass through that position, all right? So if you can't pass through that position, right, then you need to seek or pathfind around it, because that's an impassable tile, right? All right, you want to render or draw sprites associated with your map tiles, and you may use a tile set or just simply draw your obstacle sprites. Example, a white screen with just mountains. That's it. I mean, that's all I would need. Or a white screen with walls. That's okay too, right? As long as the scene is interesting. The more interesting you make it, the higher your marks are going to be. If you make it really boring for me, you're going to probably lose a mark. Be honest. Like if you make it like just like that, I mean, that would be really very little thought. And there's 2 of you, then that would be very disappointing. All right. So that's the create this part, the interesting map. Number 4, each tile in your map should have a cost value associated to passing through it. We didn't do that today, but that's smart tile stuff. So we'll do that next week, okay? Each tile should also know which other tiles are connected. So that means they need to know, each tile should know about other tiles. Like adjacent tiles that you can walk to, right? And what their values are. I should be able to poll or ask each of the other tiles, if I want to go up, can I go up? If I want to move from one place to the other, is the tile above this tile impassable? If so, then I won't be able to move up. If I can move to the right, and if the tile is impassable, I can't move to the right. But if down or left, it's not impassable, I should be able to move down a tile or left a tile, right? The only movement you'll be able to do is up, down, left, or right, just to simplify things. We're not going to do diagonal movement in this simulation, okay? Next. Determine a starting tile, start node, and an ending tile, goal node. Set these points to challenge the seeker to determine the shortest path. That means, please don't put the start tile and the end tile next to each other. That means the path is 1, right? That's dumb. If you do that, you'll lose 5 marks, right away. If you make it so that it's interesting and you make them put them away somewhere, then I'll give you the full 5 marks. What that does is start tile and end tile, you have to specify some criteria. Again, talking about smart tiles, you have to program that. They're going to say, this is the end tile. This is the start tile. And there's going to be things we check, conditions we check to see how you're going to set up your path. All right. Use a pathfinding algorithm of your choice, Dijkstra or A-star or something else, to allow the seeker to find the shortest path to the ending tile. You may use any heuristic that works best for your simulation, which means you can use Manhattan distance if you want to use Euclidean distance if that works for you. You can do that too. You can use anything that makes sense. And we'll talk more about different heuristics again next week, okay? So you have to set up a heuristic. And then move the seeker along the predetermined shortest path to the end tile. I think the key word here is predetermined, which means don't move and then pathfind. First pathfind, find all your paths, find the shortest path, and then move the guy where he's supposed to go. All right, that's what I want you to do. In this case, your program should allow the starting tile to be different every time, within reason. Wait. Provide 2 or 3 different starting points and provide the ability for the player or the user to select them and restart the simulation. So that means that, okay, so I've got a starting tile here, here, or here. Which one do you want? This one, or this one? Maybe you give a player the ability to select. So I don't know, choose that one. Okay. And that's where the starting tile is. That's the player where he spawns. And then when you start the simulation, maybe a start button or maybe it starts as soon as you click it. I don't know. And then it's just pathfinds. That's what it does. I don't need you to draw the path. So I don't need you to, like someone asked earlier today, where do you want to draw? Do I have to draw the shortest path? Don't draw the shortest path. Just go the shortest path, right? Your program should allow the starting player to move things around, right? Like I said, and show the total path costs in a UI label in an appropriate spot on the screen. So somewhere on the screen, show how big is that path, and maybe you want to make the path equal to 1 every single time. So each tile could be even if you want, right? If you really want to be challenging yourself, make tiles different costs. So if you walk on the the road, it's 1. If you walk on the grass, it's 2. If you walk on the, I don't know, the scrub or some kind of mud or in a marsh, 3. Or whatever. I'm just saying, right? Or you can just make it all 1. Doesn't matter to me, right? At the end of the day, it's pathfinding, however you do it, right? And so add it up and show it on the screen. So it's like 13 costs, or 10 costs, or 4 costs, or whatever it's going to be, right? All right, next, bonus, if you really want to challenge yourself, right? Randomly generate your map and obstacles, ensuring there's at least 1 viable path for the seeker to find. I mean, procedurally generate your map. Yay! You're like, wait, Tom, that's impossible. I can't do that in 2 weeks. Yes, you can. Literally just smack everything. So first pass, random stuff. Second pass, create your path, right? Maybe 2 or 3 of them. 3 paths. And once you create the path on the tile, you wipe away the mountain. So there's a mountain that's impassable, and you put a road there, mountain gone. First pass, second pass. Randomly generated stuff. So you have a solution somehow, right? Cool. And it's randomly, also the path will be randomly generated somehow. Guys, it's if you want to challenge yourself. If you don't want to challenge yourself, it's okay. No one needs to challenge. It's 5 points. It's 5 marks. Notice it's not 2 or 1, like assignment 1. Yes. Part of no. Bonus is bonus. If you don't get it, you don't lose anything, right? Bonus is always bonus. It's like optional, all right? Number 2, add an enemy that can defeat the seeker, right? So the enemy seeks to the seeker, tries to find you, right? And maybe it starts somewhere else, and its goal is to go to you. And if it sees you, and if it touches you, you're dead. Something like that. Yes? We'll talk about it after, right? Add music and sound effects. This is easy. You should all be able to do this. Add a start screen and end screen. That should be pretty simple as well. Wipe it away and do it. We'll talk about that as well. Add a scoring system that provides score based on the path cost or something like that. Talk to me about if you want to add a scoring system. Maybe you somehow can defeat the enemy by shooting a bullet. I don't know, right? But remember, everything's automated. Your hands off. As soon as you press the path, your seeker will seek the path and try and find the shortest path to where he's going. Submission details. Name your project assignment 2 dash, and your partner names should be there, right? So partner 1 and partner 2, whoever they are, right? Again, please don't ask me for multiple partners. I really like to work with this guy and this guy. No, it's one person. If you like to work with both those 2 people, pick one. The other person can work on his own. Or with somebody else. A zip archive of your project files. Please do not give me RAR files. RAR files can really be not working, right? Especially if you give me the wrong RAR archive or some weird compression. I will not be able to make your stuff work, all right? And that would be 0, right? Please test your files to make sure they work, and especially when you hand things in for assignment 1. So hand it in, then download it from the stuff you handed in and test it to make sure that it works. If it doesn't work, I can't do anything with it, all right? A short text document including the names, student IDs of the people that worked on the project, how your simulation works, the controls to start, stop, and any interesting or bonus features you added. You can also add this in the submission text instead if you don't want to add in a document. You can just add this stuff into this. When you submit, you can have a little area that you can put some stuff, put it in there. Doesn't matter. As long as I can understand what to do. Also, what I want is for each of the people that work on your assignment 2 to submit. I don't want just one person submitting. I want everyone submitted. And your submission should be the exact same as the other person. Please don't try and submit separately. Is that a hand? Oh, makes sense? Questions around assignment 2. This is due 2 weeks from now at midnight. No? Sure? All right. With these 2 assignments, assignment 1 and assignment 2, you should have the basics of steering behavior and the basics of pathfinding, which is what you need for assignment 1 for AI. Alex will be doing more with you in the second half of semester where you can build on these kinds of concepts to make something that's more interesting. He may ask you to make a multi-assignment project maybe a couple of little assignments that he wants to make, so he can make a little game with the stuff that we've been given. All right. So just be prepared for that at the end. It could be 4 more assignments of 5% each, or it could be 2 assignments of 10% each, right? But either way, it's going to add to the same amount that we had earlier, which is 40% for total for assignments. I've given you 20% of those. Your exam, we have talked about that a little bit as well. I know this is all administrative stuff before we get to the actual tile stuff, but the administrative stuff is important because your exam, like we mentioned earlier today in lecture, is going to be 2 weeks from now, right, on week 7. And you guys have chosen multiple choice true, false, which is fine. But just be careful because that could kind of backfire. All right. A couple things to note. I just want to, before I get into this other stuff, is I mentioned earlier to the class before me, there is a really cool project you can try and add into your project, especially when it comes to assignment 1 and assignment 2. It's called I Am GUI, or actually it's called Dear I Am GUI, right? And I Am GUI is a C++ project that allows you, that gives you buttons and sliders and a bunch of really cool things. You include it in your project, and there's some really great examples of how to make this work. I will try to add this in to your project before the end of the middle semester, right? So you can have a project with STL that works with I Am GUI. I haven't seen something that I can use yet. I have to do it by hand. But what it does is it allows you to do something like this, a little kind of window that comes up on your machine, and that allows you to do things like, okay, I want to enter some information. I want to change a slider. I want to press a button, and you don't have to do any of that work because that's kind of extra. Yeah.
Not like the video you showed us on. They were
yeah, exactly what they use. They use I Am GUI, something like that, and they just have these little things. They just like modify their stuff. So you're creating a little simulation, and instead of me having you to do buttons on your own, something exists, and it's really good. We use it all the time, right? I Am GUI. And I'll show you what we did in another project. So again, you can do buttons with little red, green, and blue. You can change that. They have other things that you can do with bindings. So for example, here's some gallery of stuff. Here's an example of like something, multiple windows that you can do, almost like creating your own little application, right, with I Am GUI, right, which is basically, that's what it is. I mean, buttons, windows, you can create menus, really cool stuff. So take a look at this. I think it's worthwhile as some kind of integration if you're interested. I'm going to try and get it going. Again, not sure if it's compatible with this deal. So that's some hints on what I'd like you to try and do. Let's get back to what we talked about before, which is getting your project going. So again, I gave you guys a template that's online. And the template that's online is called version 4. No, don't panic. It's just version 3 reskinned. Like really nothing different. I'm going to make a new folder here for version 4. A new folder. We'll call this session 2. This is like lab, the second part of the lab. And I'm just going to copy this template 4, which is clean, into this one, and we'll just do all the work again. All right, so what I want to do today is I want to create a tile grid-based system. The questions for you guys is this. What am I creating? Am I creating a grid class? Am I creating a tile class? Am I creating a grid and tile class? What am I doing? Yeah. Each tile, okay, so tile class, yeah, I agree with you. And how would I represent the grid? There's different ways of doing that. Columns and rows, I could use an array. That's what we did earlier today. I could make a grid class. I could, right? But it's almost like I'm inheriting from something when I do that. And there's got to be a reason why I'm making a grid class. The grid itself will have to be smart as well, right? So it depends on what I want. Do I want smart tiles or do I want a smart grid? You know, how do I do that? What? Both, maybe. Let's see what happens this week, and we'll talk about making it smart next week. Okay. So again, I'm just pulling up the solution. This is template 4. Even though I have .git, I'm going to erase it. I'm going to put up a new Git repository later today that I will point to. Okay. Let's start off Visual Studio and see where we're at. So when we start off, I've disabled the movement of the seeking and all that stuff, but we need to clean up our project a little bit. Hey guys, do me a favor, and your instructor, you know that guy that sits in front of you once in a while, right? Like every Thursday, right? Make it easy for him and clean up your project when you hand in your assignment 1. So if there's stuff in your project that's irrelevant, example, island, you know, ocean, cloud, get rid of those things, right? Like literally get rid of them, like take those boxes out. I don't need them, right? Make your project as lean as possible, okay? So here's what we're gonna do starting today. We're gonna start cleaning this up a little bit. But we're gonna start with things that are inside of my game. So if I run this thing, it's gonna regenerate the garbage files, the IPCH files and so on. It's gonna do that right now. So this is step 1. All right, we have this example, and again, I can move my target around. So what? But really, I've got this ship, and that's all I have. So if I look at my game.h, let's go to my game.h, guys. In my game.h to clean up, I don't need player, islands, ocean, or cloud. I can get rid of this stuff. Let's do that. So whoop. And when I do that, of course, I'm going to get some errors, right? It's going to generate errors down in here, this little red mark over here. So it says, hey, player, island, ocean, and cloud does not compute anymore. So I got to get rid of this stuff. Here's my cloud stuff. Get rid of this stuff too. And because I did that, and there's none of that reference in my game.cpp, let's do some cleaning. In my game.cpp, well, I can't really create objects that are of those types, and I've kind of commented them out. Let's just clean that commenting area out. So I'm not going to need those anymore. But at least not for now. I just clean those areas up. And this whole area up here. Okay, clean. Now, to really clean it, I have to also get rid of this stuff, right? Like my cloud, you know, my other stuff in here. For now, just to save time, I'm not going to do that. That's for you to do. And remember, when you do that kind of stuff, also in your GameObject.h, there's also this stuff. Maybe you want to clean some of this stuff up too, the types, because it won't be available. Yes? Question? Right. Okay, so going back to this then. So I've got my game.h, and right now I don't have a tile. I just cleaned it up a little bit. So I'm going to just close this up just for now and make the new tile class. First things first. So one thing to note also is up on Blackboard, I'm going to need some kind of representation to display my tile. So if you go up on Assets in my content folder for week 5, there is a little tile asset, right, that you can download. It's the tile.png. Please do that. And when you download it, I'm just going to grab it from my other project that I worked. So in my session 1, in my assets, in my textures, I have this tile.png. So that's where you would download it. You're going to put it inside of session 2, inside your assets, inside your textures. I'm going to kind of teleport this in. And what does this look like? I've used Fireworks, but you can use your favorite program to do that. All I've literally done is made a tile of a specific size. Now, we decided in the first section that our tile size is going to be 40 by 40. And the reason for this is because if I look at the calculator again, I know that my screen is 800 by 600. If you made it 32, like we talked about earlier, if I said 800 divided by 32, that's the width. I'm going to get a tile width of 25 tiles, right? And that's okay. But what about when I divide 600 by 32? 600 divided by 32, and I get like 18.75. That means like there's like one tile that's going to be split, like 3/4 of it's going to be split on the bottom, and you can't see it, right? So it's kind of an odd number, right? And typically what I like to do is try to make my tile size relative to my screen size, so something that works. And we decided earlier that it's probably best to use a tile size of around 40. It could be 40, it could be 50, something that makes sense with both 800 and 600. So if I said 800 then, divided by tile size of 40, we're going to get 20 tiles wide, right? And then if we said 600, right, divided by 40, our height is going to be 15 tiles high, right? So that's why we've decided to make this tile. And if you notice when I click on the tile itself, this tile itself is actually, well, this is 38 by 38, but this whole tile is 40 by 40. That's what I've given you. I've given you that tile. If you go up on Blackboard and download it, it's already made. I've used kind of like this greenish, neon green kind of color to denote a debug tile, because I'm never going to draw my tiles. I'm drawing them today because I want to show my grid. I want to be able to show my grid and hide my grid. And my figuring is, hey, let's make it so they're just square tiles, right? But in the future, you could have actually drawn this with STL functions to draw the top border, the side border. I'm not going to do that. I'm just going to literally make it a texture. We don't have a draw function that draws lines right now. I'm not going to recreate that because it's out of scope. In a game engine, maybe I would. This is not a game engine. This is a simulation, right? So that's why I'm doing it like this. Good? Yeah.
So the images are not actually related, are actual files.
Well, they are. They will be. They will be related so we can see where the tile is.
Yeah, that's what I mean. But
it won't actually represent. It won't actually show anything else.
yeah.
If I want to show things in my tile, then I want to. Might want to show values, like what's the value of this tile and so on. We can play with this value in different ways, right? But for now, no. For now, it's just going to literally be a tile that we're going to draw. All right, so we've got this tile, you've got it, and you've downloaded. The other thing we need to do is we know that my ship, that also has to change. Wait, that also has to change because my ship is 55 by 64. It's going to be too big for my tile set. And what you want to do is you want to scale your tile set so that it's the same size as your tiles. So my tile, which is this one, I know PNG loader, you like that? So here's my tile. My ship is, again, is 55 by 64. That doesn't make sense. I'm going to rescale my ship down to another level. So I'm going to kind of take my ship and move it down to like a 40 by 34. And then I'm going to modify canvas. I'm going to trim my canvas so that it's the right size. Now, probably some of you are going to complain that you can't do this kind of work because you're not artists. Again, it's like super easy to do, but maybe you don't have the training for that. So I'm just going to add one in here. So go add item. We'll say scaled down ship, right? So now this is a ship that's 40 by 40. Ship is now 40 by 40. Wait, please let me finish. And what I want to do here is I want to go into my tile set, right? And I'm just going to literally take this ship and I want you to replace your ship with mine just to make sure it's the right size, okay? Or you can just like literally, do it on your own, right? So again, if I did this and I scaled it down 35 by 40, right? Then this ship assets in my session 2 templates should also be 35 by 40. Where does it show me that? Sorry, I just want to make sure it's the same size before I put it up there, and then you're going to be mad at me. And that, oh, the size is 52. It doesn't really show it here. I think it's probably right, but let me just try this out. So I'm going to go here and just drag and drop, and hopefully that'll be good. Just replace this ship, your ship that you have in your textures with this one, and this will be a rescaled down version of your ship so that it works. Scaled down ship. That's 40 by 40. It's up on Blackboard for those people who can't do it. Yes, you were asking a question. Okay. So, so now that I've scaled everything down, I know I have my options or my objects that are going to fit, right? I'm going to now get back to the coding part. So I've got my objects. I know what I'm going to fit. My circle should fit, which is my target should fit. So what I'm looking to do is create a tile class. Right? So again, I'm going to do it the other way. I'm going to kind of right-click on my header files. I'm going to add a new item. I'm going to call it, it's going to be a header file, and I need to make sure this is the correct path. So I'm going to browse into my source folder and select that folder. And then my header is going to be called tile.h and add. And then I'm going to go into my source file, do the same thing. I'm going to add a new item. I'm going to go to CPP. I'm going to change this to tile.cpp. Make sure that this is pointing at the right place, which is your source. Should be pointing at source still, right? And then click add. And now I've got my tile.cpp, my tile.h. In my tile.cpp, I got to do two things. One, I'm going to include tile.h, that's for sure. And I'm also going to include game.h, because I'm going to need that later on. All right, those two things. That's in my tile.cpp. Going back to my tile.h, again, I'm going to use that if not defined syntax, the pre-compiler syntax. I'm going to go into my one of these things like my ship as to get an example. I want to just grab these two things right here, if not defined, and kind of put that in here inside my ship. Sorry, my tile.h, and let's just call this tile. And what this does is it checks to see that this has not been defined. We're missing the bottom, and again, to make it quick, I'm just going to, for consistency, I'm just going to grab the end if and put it in the tile. We've done this many times now, so you should be able to do this kind of stuff with some level of competency. Okay. Basic stuff, yeah? We've done classes before, but I've done this a bunch of times now. You should be able to be comfortable with this kind of process, right? All right. Are you with me? I know I'm going fast. Kind of. All right, let's get in there. So number of things we have to do. One is I want to make a new tile class. I'm going to make it a GameObject, and we're going to see why. Class, tile, inherits from, make it space, public, GameObject. Uh-oh, we can't do a GameObject unless I include GameObject. So let's do that now. Number include GameObject.h. We need that for sure. So now I can say public GameObject. It inherits from that, right? And what I want is a public section and a private section. Oops. Right? Those two things, public and private, yeah? I also want to render my tile out, and if I'm rendering something, I'm probably going to need Texture Manager. So I'm probably going to load this in as well. So I'm going to say in here, I'm going to say include Texture Manager.h. There we go. Here's Texture Manager.h. I need this, right? And to save myself trouble, I don't feel like including stuff that's already been included in the GameObject. So I'm going to click on the GameObject Superclass like this. I'm going to right-click onto it and go Quick Actions and Refactorings. And what I'm going to do is I'm going to select Implement Pure Virtuals for Base GameObject. And when I do that, it's going to go bam. And Visual Studio is going to do some work for me. It's actually going to create these three functions, which I'm going to take and put them inside the public area. Along with two more functions that we need. I need a constructor function for the tile, and I need a destructor function for the tile, right? Those two things. And they need to be defined. So I'm going to click on this little light bulb and go to Create Definition. Same thing for the destructor. I create declaration definition, sure. And once I've done that, I've got kind of the building blocks of my tile, right? Are you with me? There's nothing different than we haven't done before. This is a GameObject. Now, there could be people out there when they're watching this video, they're like, wait, oh my God, you're making a tile with GameObject, Tom. It's so huge, it's massive, it's going to take up a lot of memory. Maybe. But for our purposes, for this little example experiment, it is not a game engine. We're not making a real game out of this. This is for demonstration purposes only. So it's nice and easy and quick and dirty, and that's why we're doing it, okay? Cool, we got our tile, and we want to render something with the tile. And for us to render something, we need to create some stuff in the tile.cpp, which we already kind of have a pattern of in your ship.cpp. So let's look at the ship.cpp as a pattern, right? So here's my ship.cpp. And my ship.cpp has this. I definitely want to include my util functions because I know I'm going to go there. Let's put that in my my tile.h. Oh, my tile.cpp, I mean, there it is. So I'm probably going to use a util function somewhere. So I have my util functions going, why not? And the other thing I'm going to add is all this, but I'm not going to do all of this because I don't need like, you know, setting the type and all that stuff. But hey, just for posterity, right, and to be consistent, I'm going to go to my GameObject.h file, and I don't have a type for the tile. I'm going to add one in later on because you're going to be nice to your instructor. You're going to go here and clean up this area and remove stuff that's irrelevant, like island, player, cloud, probably bullet, enemy, ocean. Get rid of all this stuff, right? And get rid of all this, some of the stuff that you don't need over here. Right? Right. All right, so now in my shift.cpp, I have examples of how I want to do stuff. I do need position. I don't need velocity and acceleration for my tiles. My tiles are not going to move around the screen. So I can literally just get this part right here, these 1, 2, 3, 4, 5 lines of code, copy them, and I'm going to go back to my tile.cpp, and inside the constructor function, I'm going to paste them. And just to make it clear, inside my constructor function, I'm going to make sure that this point, the texture points to the tile texture we just made, and it's going to be called tile, and my texture size is going to be of type tile. And you know what, for just to start off, my location is going to be 0.0 F and 0.0 F. You can probably leave them at 0.0 instead of the F. Heck, you can even just use a GLM vec2 and it'll do the zeros for you. But we're going to be explicit, yes.
But just to be clear about that contract.
Yeah, GLM is a graphic library that we're using for math, a graphic math library, and we're using a vector2 object to define the position of the tile object. That's what we're doing, okay? All right, well, we also need to draw it and update it. There's no update, there's no clean. All we need to do is draw. So let's see what that looks like. So shift.cpp, what does the draw function look like? Well, this looks good. However, if I go into the tile.cpp and put in the draw function, I can't do this because there is no current direction. So let's leave that at 0. And we're also going to change this draw to draw the tile, not the ship. And then the drawing is good. Now we can draw tiles. Okay. By the way, this draw function is to draw the debug of the tile object we're going to show just for debug purposes. We're never going to show the tile in real life. We're just doing it because we want to see the grid. Yeah. 0 represents the angle of how this much is turned. This is 0. I'm not going to rotate it. 255 represents the opacity, so it's 100% opaque. If I turn this down to 0, it'd be fully transparent, which is something I can do if I want to turn off the tiles, right? Or just not draw them, like literally just don't render them. Up to you. All right, so yay, this is good. We've got our tile. We want to try and draw a tile. Let's try drawing a tile on our background. Now it's going to appear in the top left corner of the screen somewhere. And let's go to our Solution Explorer. We're going to go to our game.h, and we're going to include tile.h in our game.h. Yay. Fantastic. And we're going to go down, scroll down here, and where it says that there is a ship and a target, we're also going to make a tile. Yes. What? Tile.h, the new thing we just created. All right, we're going to go all the way down here, and we're going to go to this. And, you know, I failed to name this properly. It should be ship with the capital S. Please ignore it. We'll get to it. But here, I'm going to use tile on a pointer of tile, which we're going to call m_p tile, right? That's going to be the tile, the example tile we're going to use. We're not going to keep this very long. I'm just using it for now, just to see, can I draw my tile? Is this okay still, right? We should be good. We're doing the exact same thing we've done many times. Next, now that I've done this, I want to go into my game.h, my game.cpp, and in my game.cpp, I want to scroll down to where I have my create game object, and I want to create a tile, and I want to put the tile behind the ship. Let's do that. So I'm going to say M_P tile is equal to a new tile, right? So I'm allocating the memory, right, on the heap for the tile that I want to do it, and then I'm going to go scroll down until I get to my render function. I want to render the tile before the ship, so I'm going to say M_P tile, and I want to draw the tile. Yay, here's my drawing of the tile. Because each tile is something I can draw right now because it has a debug surface. That's what I'm doing, right? And in my update function, hey, let's update the tile too. So M_P tile, and then update. There we go. This should be enough for me to be able to draw and update my tile. My update method on my tile is empty right now, so it's literally not going to do anything, all right? However, we should put it in there just in case we want to add something in there, so we don't forget. Let us start it, and we should see if everything goes well, and if you did everything that I did, you should see if you now build and run your project. On the top left corner of the screen, there should be a green tile right here, like this, see? Are you with me? Notice also that the ship has gone down in size. Ship has dropped in size because we rescaled it. It's not a big ship anymore. And the target is the same. But look, take a look at this. There's a little tile that sticks out here. It's cute. It's got a cute little button of a tile. Are you with me? You got all the tiles drawn? Yes or no? Yes? No? What happened? The what? You don't see the tile? Well, let us continue, and then I'll come over with your challenge. When your challenge comes, and we'll stop and do stuff together, okay? All right, so challenge 1. Let's do this part first together. 1, I want to create now a grid of tiles, right? And I want them to appear in my debug view. So, what kind of structure do you think that I need to make my tiles? I won't answer because you were here this morning. I want the other people to answer. Alex, what do you think I need to do? If I want to make a grid of tiles, what kind of structure do you want me to use? Well, that's how we set the tiles, but how do I make a grid of tiles? I want something to hold or make references to all the tiles. An array, okay. Just an array, anyone else? What do you say? What kind of structure do I need? 2D array, okay, we did that earlier. We could also use other structures, but let's do the 2D array. How do I make a 2D array? First of all, it looks like this, M tile, right? But I want to do 2D array, I can use this kind of stuff. Isn't this good enough? Do I have to do anything? I'm getting errors. What do I do here? What do I put in my 2D array? Right? My tiles array, right? I'm not going to call it tiles, by the way. I'm going to call it grid. M_P grid, right? That's what it's going to be called. And, whoa, I need to put values in here. Now, what if, and I showed this earlier, can I do this? Can I do like int row, let's make it a const int row, and I'll make that equal to like, I don't know, 20, and const int column, I'll make that equal to 15, and then I want to put like row and column here. Can I do that? And if not, why? How come it's giving me errors? Come on, guys. What's the issue? Why am I getting this problem? What? Row and column? I mean, they're right here. What are you talking about? Huh? I mean, they're right here, though. What do you mean? They're totally defined. Yeah. No. It has to do with the fact that row and column won't be defined fast enough for this M_P grid to be defined. So when I kind of create this thing, row and column will never appear in here. That's why they need kind of a 20 and a 15. That would totally work, but this won't work. Now, it's nice to have row and column inside here, but for other purposes. So for example, if I want to keep track of M_rows, like a row length, and M_column, so So I want a row size and a column size. Let's call it row size. I didn't do this earlier, but it might be a good thing to do. And a column size, that might be good to keep because this way it's not hard coded, right? So when I actually run my code, I can have a row size and column size of a certain point. I can also update this later on. But for now, you can see that 20 and 15 is what I have. Also, we want also to calculate, the offset. Typically my offset is going to be, my actually tile size is going to be 20 or 40, I mean, right? So I could say that like const int, m underscore tile size. My tile size is also to 40. I could do that. So this is all like, I'll put this on. This is all like, tile in grid variables, right? All related to the grid stuff. So I have all this, 20, 15, and 40. I know this information, right? Curious. This stuff, this initializing stuff. Right now, if I did it here, but it doesn't work here, will it work in my game.cpp? Will I get a value? Well, first of all, let's correct the errors. So here, I'm saying I want a new tile. Well, I can't just do new tiles. I want to create multiple tiles. And I want to create my grid is what I want to do. And I don't really have a function for that. I don't like creating it inside my create game object. It's pretty messy. Let's create a bunch of functions, utility functions to help us. So one is, let's make some utility function for that. So I'm going to make utility functions for tile and grid. One of them is going to be a new function called m underscore create grid. I know I want that. I also, when I create my grid, what am I really doing? I'm actually instantiating a bunch of objects, running a nested for loop, and putting those objects inside of my multi-dimensional array, two-dimensional array, right? And I'm going to use row column format, right, for my array. Now you can use whatever format you like, but that's just natural for me. And then when I have my grid, I want to be able to draw my grid and update my grid. I need those two things too. So void m underscore draw grid, and then void m underscore update grid. So those are the things I need for sure. I mean, again, I don't have to put it this way, but I'm choosing to because I want to compartmentalize a little bit, and it makes it a little bit easier for you to follow. So update my grid. Do that one now. And I just kind of created that with the help of Visual Studio. So I've done that right now. Create grid, draw grid, update grid. And I have those functions in my game.cpp. Right there. So when I create my grid, I need a nested for loop, right? So again, I've just created 3 functions just to keep you guys on track, right? I want to draw my grid up, but I want to create my grid. I want to instantiate objects of type tile and store them in my grid. All right, that's what I want to do. So in order for me to do that, I'm going to do something like this. I'm going to say that I'm going to have my for loop, and if you type for in Visual Studio and then double tab, you actually get this, right? And what you get is for my size T is fine. What I want to do is I want to change the type to row, and my length is going to be m underscore row size, right? And I'm going to do the same thing for tab, and I'm going to go column is equal to m underscore column size, right? Which we've done before. We've kind of created that structure, right? Row, column. And then what I want to do here is when I create my grid, is I want to use my structure, m underscore p grid. I want to say that for every column and row, I'm going to make a new tile, right? Here's my new tile. But here's my challenge now. I want to be able to position my tile. I give it a position, each of my tiles, right? That's what I want to do. And I want to give my tile a position that's relative to the column and row that I'm on, right? Now, right now, I cannot do this. I'm going to run into a problem because my constructor for my tile right now is only an empty constructor. That's all it is. It just doesn't do anything. It's actually the default constructor. I need to add a structure to my tile so that it can hold a GLM-vec2 object, right? So before I do this, right, for now, let me just put this so I don't get an error. And let's just clean up the rest of the stuff I got to do. So I want to come in here. This create game object, I'm going to call my m underscore, again, create grid. So I'm going to kind of clean that up. And then these errors here are the same. This is going to be my draw grid. So m underscore draw grid. I'm just replacing the errors so that way there's no more errors. And then m underscore update grid. Again, these are all functions that I created. Going back, so you see everything. In my game.h, I made 3 functions: create grid, draw grid, and update grid. And inside my game.cpp, I literally just call those functions right now that are empty. Up at the top, here are the functions. Here's create grid, here's draw grid, and here's update grid. And they don't do anything, the other ones. But for now, I need to do something here because I want to reposition my tile. Otherwise, all the tiles are going to be in the top left corner of the screen. I want them to be repositioned on creation. When I create them, I want to reposition them, right? So in order for me to do this, I need to change my tile constructor so it's different than this. So I'm going to go to my tile.h, and inside my tile.h, notice my constructor doesn't take any parameters. I can make it take a GLM2 vec2 object like this. I want to take a new GLM vec2 object, right, which is going to be called position. And I want to instantiate a new GLM vec2 object in there, like this. So what does this do? This creates a default GLM vec2 object, whether I include it or not. That's what this does. Now what I need to do is take this right here, this part, and go to my tile.cpp and change the signature so it looks like this. All right, so again, tile.h looks like this. So a new GLM2 object, which is called position. I'm instantiating a default object in there, so whether you have it or not, it just makes one, right? And then in my tile.cpp, I've included this position. And instead of setting a position down here, which is a new GLM vec2 object, I just pass in the position object I just created, like this. All right? So this position is passed over here. I set position when I'm creating the object immediately. So that way I can set exactly where my tile is going to be upon creation, right? Again, this is one way of doing it. There's many, many ways of doing the same thing, all right? But this is one way that makes it easy for you guys. Are we good? Anyone not good? Not good errors or not good understanding or too fast? Hear me? What do you want me to go back to? Tell me what I want, what you want, what you need. Okay. All right. All right. Okay. Okay. Well, I'll put this up on GitHub later on. Yeah. The what? When I create a tile? Okay, go back. Say game.cp, yeah? And the game.h you mean? Or where? Yes, this is a grid of tiles. So grid of tiles, an array of tiles. That's what this is, right? But it's an array of tile pointers. That's what this is, array of tile pointers, right? So this array of tile pointers is where I've got I'm going to store my tiles. So going back to my game.cpp, let's get rid of my ship and ship.h for now because I don't need them. Going back to my game.cpp, inside my create grid, this isn't good enough anymore, right? I want to add a new GLM vec2 object for my position. So GLM vec2 And inside there, what I want to pass in is my column and row information. So I want to say that, well, if my column is 0, pass in 0. If my row is 1, pass in the row. I want to be able to do that, column and row. However, this isn't good enough because that would be 0, 0 all the time. I want to offset it by 20 because remember, it's the middle part of my thing is being drawn. I want to move my column, my grid over by 20 and down by 20. That means I'm going to add 20. That's going to be my offset, right? And I'm going to move it down 20, so row. Actually, I did the wrong way around, so it's row column instead of column row. I'll be okay. It's okay, I figured it out. And then, because that's going to be messed up if I don't do that, right? So 20 and 20, because what I'm doing is I'm going, okay, move down a row, whatever, 0, 1, 2, 3, plus 20, so it's going to go down 20. But then I also have to multiply it. I want to multiply it by 40, right? So I want to say something like row times the tile size, so m underscore tile size, plus 20, and then column times m underscore tile size, right? Plus 20. So what this does is it says, okay, I'm going to make a new tile, and it's going to be the position of the new tile is going to be at, so starting off at 0, 0 times tile size is going to be 0, plus 20. So it's going to say, okay, move over 20 and down 20, because the tiles, the row and column are going to be 0. On 1, it's going to say, okay, take 40, it's going to be 40 across, plus 20, plus 40 down, and 40, and I'm just going to call it, and 20 more. So it's going to be like the exact position of my rows and columns as it goes down, right? So this is how you set up the row and column, and I'm doing it on creation. Again, there's tons of ways of doing this. You can do it separately, you can add, you can reposition everything later on. Yes? No? That's this. That's the row size and column size. The row size and column size are going to be 20 and 15, but the tile size is always going to be 40 by 40, right? I did that over here. By the way, curious, is this even going to work, like I talked about? Let's see what happens. I love when stuff goes awry, right? So, okay, so cool. So we've got this stuff, and then my draw grid. I'm going to kind of do this again, right? I'm going to do this again for my draw grid. I'm going to do all this double for loop again. So first I create it. I only create it once, but I want to draw it and update it every frame. So I'm going to kind of do one of these, right? I'm going to copy paste. But instead of having all this new tile stuff, I don't want to create a new tile every frame. I want to access the object that I have in here, which is my tile, and then I want to draw. So draw that tile, right? This tile here in my grid. The tile at column row location. And the same thing goes with my update. Yes? Oh, crap. Let's fix that. No, that was wrong. It's actually row column. I'll be okay. Woo, that would have been a mistake and a half. Row column, I'll be okay. I don't know why I've been saying column row. Row column, row column. Row column. Yay. I'll do the same thing. Thank you for that. I'll do the same thing with my updates. And instead of draw, we're just going to say update. So now I have a separate draw function, a separate update function, and a separate create grid function. Now, guys, here's something to note. If I had a grid class, I could hide all this implementation in the grid class, right? Where I can just call, hey grid, create yourself. Hey grid, update yourself. Hey grid, draw yourself, or not. I'm just saying, right? We don't need another structure right now, so I'm not going to do that, right? But you could, right? And it's not going to be wrong for you to do it. All right, so I did this, blah, blah, and if I did everything correctly, then we should see the grid. However, I know I'm not going to, one more cleanup thing. In my handle events function, in my game.cpp, I'm not going to need to move or turn my ship anymore. So I'm going to get rid of everything that has to do with a ship, which is this stuff. So all this, going to get rid of it. I'm never going to move the ship again. It's going to move for me by pathfinding. Right, there it is. WS, these are all controls for the target. And that should be good. We should be able to run it, and you should see if I didn't make a mistake, and if somehow those variables worked, I should see a grid like this. Now here's the thing, my ship itself is in the middle of the grid because we didn't reposition it properly. We're going to do that. So for those people, hello world, challenge. Here's the challenge. And we're gonna stop recording. I'm gonna come across and help you guys do the challenge. Challenge. I want you to spawn 5 ships randomly and position them correctly in the grid. Right? That's what I want you to do. 5 ships randomly spawned and put in the grid. For now, for this iteration, I don't care about overlap. So if they overlap and you only have 4, and then the next time you run this, you have 5, it's okay. In the next iteration, next week, we're going to have a smart grid that knows what's inside of it, right? And we'll be able to detect to see that there's a ship already in there, okay? So for now, all I want you guys to do is just for your challenge, and this is for your exercise, spawn 5 random ships and position them inside the grid, okay? So I'm going to stop recording now, and when we come back, I'll try and propose a possible solution.